Hey, we're here with Bernardo Petit from the European Space Agency, and today we're going to be talking about the Orion service module. Bernardo, how are you doing?
I'm doing fine. Thank you very much, and thank you for being here.
How is ESA going to be leveraging the ATV technologies into the Orion service module?
Right. Let's first see what is the service module. Let's imagine it as a big truck, which is pushing the crew module. So what does a big truck needs is an engine. So essentially, it's a big propulsion module.
Okay.
That's where the analogy stops, because it provides also other services to the crew module: power, storage of consumable, heat rejection. So many of these features are already built in onto the ATV propulsion module. So we are going to use similar architecture and put together similar equipment. Sometime we are going to customize it and make it work for a beyond LEO mission.
And also, you may be putting in some cutting-edge technology into the vehicle as well.
Yes, we are using similar technologies for the propulsion elements,
right,
where we are using the main engine is a US-provided engine, right, from the shuttle.
Right.
We are using other engines that were already in the ATV. On the solar panels, you can consider that the solar panels are an evolution from the one of the ATV.
Okay.
We are using some heritage, but also there is some quite great deal of innovation. The storage of consumable is essentially similar, and of course what is being customized is the heat rejection, which is quite different, and also the structure itself, because it's really mission tailored.
Since the service module will be attached to the crew module, what are some of the challenges of human rating a spacecraft?
That's a great point, Chris. Human rating a spacecraft is very different if you do a low Earth orbit spacecraft or if you do an interplanetary spacecraft. Why? Because in low Earth orbit, you are not constrained by mass as much as you are when you go beyond low Earth orbit. Now, the challenge is that, of course, the crew has to be absolutely safe,
right,
but we have also to respect the very stringent mass constraints that we have. So that's where the challenge and the ingenuity of our engineers is required, because you can't just make it everything double. If you put everything double, that will never fly. It will be totally safe, and it will be even safer because it stays on the ground. So it is a mix of redundancy, cross-strapping, reliability, and clever architecture that we have to implement in order to have it human-rated to guarantee in the end the full safety of the crew.
So it's very important when you do your trade studies to kind of balance all those components.
Indeed, and we are doing that in close cooperation with NASA. We cannot do that on our own. It will never work. You have always to see the vehicle as a single vehicle. There is not such a thing as the crew module and the service module. That will never work. You have to think about the Orion vehicle and to have an integrated, right, architecture that satisfies the requirement of human rating.
When we develop a spacecraft that big, it's hard to rely on just one country to build everything. Who are some of the partners for ESA in developing the service module?
Yes, it's a very articulated effort in Europe we're having to participate and build this service module. It is led by a country and a company being Germany and the company being Astrium, located in Bremen. And there are many other countries in Europe: France, Italy, Spain, Belgium, Switzerland, and some other countries that are also supporting the development of these spacecraft. In Europe, we are quite used to do cooperation within countries. That's all about ESA. The list is very long. I've just mentioned the important one that are providing hardware that then will be integrated in Bremen and then shipped to KSC for final integration and test with the rest of the Orion spacecraft.
Is the service module going to be reused every single time, or is it something that you'll have to rebuild each time?
We have to rebuild each time. The service module is totally expendable. It is being separated from the crew module before entry, so it burns into the atmosphere while the crew perform entry and, of course, land safely the astronaut on the ground.
Now, you currently work on the ISS as well.
Indeed.
How different is the challenge of, let's say, constructing the International Space Station and maintaining it in low Earth orbit, as opposed to developing this new spacecraft going beyond low Earth orbit to Mars, to an asteroid, or beyond?
This is a great question, and I'm very grateful of it. If you want to see, the ISS is a big modular house, which you can build like Lego pieces. Things have to be compatible, but not necessarily totally integrated. You can have design freedom, build a module in one way and the other one different way, as long as you plug them together and they work. A spacecraft like Orion is a totally integrated spacecraft. You can't afford multi-design philosophy in the architecture. It has to be really integrated, because otherwise you lose one thing. You lose the efficiency, the mass, and in the end, the performance of your spacecraft goes down and you don't perform the mission. As opposed to the modularity of the ISS, which has been built in various pieces, then it never suffered of the mass criteria. Okay, what you do if it is more heavy, you have a shuttle fly extra,
right.
Which is of course a bit more expensive, but it's not a go, no go. There it's a go, no go. You can't afford to have multi-philosophy for the design of the spacecraft.
You know, human exploration has always fascinated the public. And sometimes we have a challenge, you know, in the United States to get kids excited about science, technology, engineering, and mathematics. Where do you sort of see the European people in terms of getting excited about human space exploration?
Well, I guess we're not that different.
Okay.
We are facing the same challenges, and we have to explain to the community at large and to the young people that intelligence is a great investment.
Right.
It is fine to listen to pop music, to watch sports, and I love pop music and I love sport. But intelligence is something very important. Education is something important. Innovation is something very important. Now, what is the best challenge? What a better challenge than exploring the universe by sending 3 or 4 of our colleagues beyond our low Earth orbit and looking what is there. I think this is extremely exciting. There is room for all the creativity of all of us in there. You can be an astronaut, you can be an engineer, you can operate, there is room for everyone on this great trip. And I think this is the challenge of our society, to understand how much this is important.
Now, when that service module is built in Germany, are you going to find a place to kind of sign your name inside?
Well, we are negotiating that very hard, but I think we'll find a way to have and unfortunately, it's going to burn down the atmosphere. So, but at least we'll have our picture taken before the launch, close to the little encryption on the structure.
Well, Bernardo, thank you so much.
Appreciate
it.
It was nice to have you here.